All right, this is AP, AB, and BC Calculus. We're doing Unit 8, Section 2, which is connecting position, velocity, and acceleration using integrals. So let's get right to it. So most of this boils down to the difference between two concepts, displacement, which can also be called net distance, and total distance. So displacement is a vector. It has a direction and can be negative. Displacement is just my final position minus my starting position. So for example, and we'll do another example of this in a sec, but if I have a particle on a number line, right? So let's say I have a particle on a number line and it starts here, right? So let's say it starts at 0, right? My particle's on a number line. Let's say I walk 2 units to the, or 3 units rather, to the right. So 3 units to the right. I stop, I turn around, and I walk 4 units to the left. I started here, right? This was start. I ended here. My displacement is -1, right? My displacement is -1 because it is my starting value 0. Sorry, is my final value -1 minus my starting value 0, right? I ended at -1. I started at 0. So my displacement is -1. Like I ended 1 unit to the left of where I started, okay? The way you get displacement is generally just by integrating velocity. Displacement is a vector. It has a direction and can be negative. Velocity is a vector. It has direction and can be negative. If you integrate velocity, you get displacement. Sometimes the AP will call it net distance, so just have that on your heads up, like on your radar, be heads up that that's a thing. All right, so total distance is a scalar, meaning it does not have a direction and cannot be negative. It is the sum of the legs, the distance of each leg of the trip, meaning that how far you travel between stops. So in this example, right, I walked 3 units. I also walked 4 units. So in this example, the distance would be 3 plus 4, which is 7. It's how far physically I walk. So you're basically integrating a scalar, speed, not velocity. So if you have a calculator, it's pretty straightforward. You can just, instead of integrating v of t, you integrate the absolute value of v of t, which is speed, and you'll get an answer. If you don't have a calculator, it's a little bit more complicated, and we're going to spend some time talking through that. So before we do that, let's do a little bit of an explanation of displacement and net distance, the same basic thing I did on the last slide, but with me and my little Bitmoji running around like a crazy person. Normally, I do this for you in class, right? But I'm not in class right now, so here we are. So let's say I start standing at x equals 1. So we're gonna drag Hogan number 1 over here. I'm gonna start standing at x is 1. Okay, that's where I start. Okay, I run or walk to x equals 6 in 2 seconds. So I'm running, right? Run or walk to x equals 6 in 2 seconds. That's me running, and I land at 6. Okay, so that's the first thing I did. So I let's say I did this. Running or walking. Okay. I stop for a sec. I turn around, right? Because you have to turn around in order to, or you have to stop in order to turn around. So I turn around and walk to x is -3. So whoa, over to here. So let's grab Bitmoji Hogan again. That's where I landed, and we'll put a running Hogan just for good measure, because, you know, running Hogan. Yay. Okay. All right. So yay, running Hogan. Okay. So basically, the spots I have, right, if we highlight this for a sec, so the spots, so I was here, I moved to here, I landed here, right, and then little Bitmoji me's are trying to help you show that image. Okay, so what is my displacement from 0 to 7? Well, my displacement is where I ended minus where I started, right? So my displacement is going to, oh, sorry, I did one more. I'm sorry, there was one more Hogan walk. Hang on, I didn't realize. I didn't make myself enough Bitmojis. I walked one more time to -4. Sorry. Take that back. Didn't read my own instructions. So and then I walk one more time, right? So one more leg. I walked from here to here real quick, right? So now I have 4 locations, right? So I started here, I moved to here, then I moved to here, then I moved to here. Okay, so let's see that I got all of them. 1, 6, -3. There we go. Okay. So what is my total displacement from t is 0 to 7? Well, I started at the position of 1. I ended at the position of -4. So my displacement is -4 minus 1, which is -5, right? That's my displacement. And that makes sense because if you look, I ended up 5 units to the left of where I started, right? I started here, right? This was start. I ended here. That was end. I ended up 5 units to the left, hence my displacement is -5. But what's my total distance? Well, I color-coded the legs, right? On the first leg, I ran from 1 to 6, right? So on the first leg in red, I ran 5. I happened to run 5 to the right, but it doesn't really matter that I ran 5 to the right because I just can't care that I ran 5. On the second leg, I ran from 6 down to -3. So on the second leg, I seem to run 9, right? Because 6 to -3 would be 6 minus a -3, so that's 9. Doesn't really matter that I ran left because, again, we just care how far I ran. And on my last leg, right, on leg 3, I ran 1 unit to the left, but I don't really care that it was to the left. I just care that it was 1 unit. So what's going to happen is that my total distance is 15, right? So this is displacement, and this is total distance. And again, I would totally run around like a moron for you in a classroom, but instead I made little Bitmojis to run around like a moron for me. So notice that it was important when I stopped. The mathematical term for stopped is at rest, right? And that means that my velocity is equal to 0. At the moment when I stop, I could either continue moving in the same direction or I could turn around and move in the opposite direction. So if you notice, here I was moving right, I stopped, I turned around and went left, right? And then I stopped and said, nope, I'm going to keep going left. One analogy for this, right, is like is recognizing that you forgot something when you leave the house, right? Like maybe you leave the house, you're walking away, and you have this moment, oh no, I forgot my keys, and you turn around to go back, you walk back in the front door, you walk to your desk, you don't see your keys on your desk, you keep walking over and find them on the kitchen table, right? So I have to stop in order to turn around, but I can also stop and then continue moving in the same direction. Okay, so there are 3 ways to find total distance given a particular set of circumstances. I want to walk you through the 3 ways, and then we're going to see different problems where we see these things happen. So if you have a calculator, just integrate the absolute value of v of t over the integral. Like that's straight up it. If you have a calculator, you're going to integrate the absolute value of v of t over the interval. You're going to write down that that's what you're doing. You're going to say, hey, I'm integrating the absolute value of v of t with respect to t from like a to b, and you're going to be like, hey, that's great, and you're not going to write it in calculator notation, you're going to write it in regular notation, and it's great. If you don't have a calculator, but you have the equation for v, then you're going to have to find the spots where the particle is at rest, right? And that means v of t is 0. Let's call those times c1 and c2. There could be fewer than 2, there could be more than 2, but let's just say c1 and c2. Then I'm going to use integration, and I'm going to find the displacement on each leg. So from 0 to c1, and from c1 to c2, and from C2 to the end of the problem, right? I'm going to find what's the displacement on each leg, and then once I know how far I traveled on each leg, I'm going to make that quantity positive. So if I get a -7 for the displacement on one of the legs, I'm going to recognize that that means I was traveling 7 to the left, but I don't care that it's left, I just care that it's a 7. And then once I have all those different legs, I'm going to sum those values and get the total distance. If you have x of t, the position, and no calculator, you need to still find the times when the particle's at rest. So you're still going to have to differentiate and find v of t so that you can find when v of t is 0. And we're going to call those times c1 and c2 again, but again, there could be more or fewer of them, right? I'm going to have to find the position x of t at the start and at all the rest spots, and then so once I know those positions, then I just subtract to find the distance traveled on each leg, and again, if you subtract and you get that a distance is negative, you say, oh, wait a sec, I just want the distance, not the direction, so you just make it a positive. So we're going to walk through a bunch of examples, but that's kind of the gist. All right, so we're going to use a calculator on this. The velocity of a particle in meters per second is given below. What's the total distance traveled from 0 to 3? So I have velocity and I have a calculator. My job is to just say that total distance is the integral, and I can call it v of t because they called it v of t, the integral of v of t from 0 to 3, and it's in an absolute value, right? Because that is going to be speed, right? Now, if they hadn't called it v of t, you would want to write the whole function down, right? I'm going to go over to my calculator, and I'm going to put that ugly thing in y1. So I'm going to do 5x, right? And you'll find on a calculator section that a huge part of your time is just making sure you enter things correctly, which is frustrating, but it's worth the time. So 5x e to the -0.6x, because again, I'm using x instead of t here because that's how your calculator rolls, minus an x squared, and I'm going to quit out of that, right? So what I want to do is I want to do math, right, 9, and I want to integrate, so I'm going to go to math and go to abs, which is under number. So absolute value of vars over to y vars y1. Okay, so I want the absolute value of y1, comma, with respect to x from 0 to 3, right? And I'm going to hit enter, and I'm going to get an answer. So the total distance is approximately 5.817. That's it. And then it's meters because I was given units. If you're not given units, don't worry about units, but if you are given units, you need to have units, right? That's it. I don't have to do more than that. This communicates my understanding. This is my answer, and I made sure to include units, okay? If you don't have a calculator, this will be a longer problem, and we'll walk through how to do some of these other ones that are not quite so ugly without a calculator. All right, so try another one with a calculator, right? Again, you're finding the total distance traveled from 0 to 5. So if I were you, I would put this in as y1, right? Your total distance is going to be the integral from 0 to 5 of the absolute value of v of t dt. They called it v of t, so you're allowed to call it v of t in your work. If they didn't call it v of t, if they just said the velocity is given by this statement, then you would have to write the entire statement in. Notice that I was kind of lazy. I just used y1, so if I go to y1, I don't have to retype the whole integrand thing. I just have to edit what y1 is. So it's 4, and then e to the 0.3x, close the parentheses, sine of 2x, and then you should check and double check and triple check. So 4e to the, yep, that looks correct to me. Okay, so I'm going to quit out of this. I'm going to second enter, and now I need to change this. It's not 0 to 3 anymore. It's now 0 to 5, but otherwise it's exactly the same because I already have the absolute value. I already have y1. It's thinking, and I'm going to get that it's approximately a 27.705 meters. And again, you'd round or truncate to 3 places, but in both of the cases we've seen so far, those values have been the same. Again, notice I need to know the calculator notation, but I'm not getting credit for calculator notation. I can't call this y1 in my integrand. The AP is going to eat you alive. It doesn't matter if you called it y1 here. It doesn't matter. You have to write what the function actually is. All right. So this is non-calculator, though we can use a calculator to check. So the velocity of a particle in meters per second is given below. Find the total distance. So if it's non-calculator, the first thing I need to do is find when my particle is at rest. So I need to find when 3t squared minus 8t plus 5 equals 0. My guess is that this factors. Might not, but it probably does. So I need a negative 8. These have the same sign. I'm pretty sure that I want a minus 5 and a minus 1. This will give me a negative 3t and a negative 5t and a plus 5. So I end up getting that t is 5/3 or t is 1. Right? Those are my 2 spots. So I was asked from 0 to 2, right? So basically what that means is so the first leg, right? The first leg is going to be from 0 to 1, right? The next leg, right? So then the next leg is going to be from 1 to 5/3, and then the last leg is going to be from 5/3 to 2, because 2 would be 6/3. So there's basically 3 integrals that I need to find, and it's not fun at all. I'm just going to throw that out there. Not fun. So essentially, what's going to happen is I need to find the integral, right? So I'm essentially going to find the integral from 0 to 1 of v of t, the integral from 1 to 5/3 of v of t, and the integral from 5/3 to 2 of v of t. And then after I find each of these, I'm going to make the result positive. Notice this is not the same as integrating the absolute value, because that's something you need a calculator to do. So one point I'll make here is that it's kind of worth figuring out what the ni derivative for this thing is ahead of time. So it's worth saying, wait a second, I can figure out this ni derivative once without bounds. Sorry, that's a minus 8t plus 5. I would argue it's kind of worth figuring out that this is a t cubed minus a 4t squared plus a 5t, because then you can just use that for all of these values, right? So you don't have to do that, right? But this is helpful. And I'd probably just label this as work and be like, cool, so that's work, I'm good. Okay, so now that I know that, right, I know that this is going to be t cubed minus 4t squared plus 5t. I think it was a minus. Let's go back and double check. Yeah, it was. From 0 to 1, right? And I'm kind of going to cheat. Like so you're going to absolute value this whole thing when you're done. You could also just individually do the work on each separate leg and then find the value and make it positive. It doesn't matter. So you can either treat it like this, or honestly, the way that I frequently do it is I just look at each leg and I'm like, hey, the first leg would be t cubed minus 4t squared plus 5t from 0 to 1. Well, that's going to be a 1 minus 4 plus 5, minus a bunch of 0, right? So it seems to me that that's a 2, right, because that's a 6 minus 4. The second leg, right, is going to be the one that's the worst, I would say, of the well, neither of the other two are fun, because, you know, once you get rid of the 0, life is less fun. So this is going to be from 1 to 5/3, right? So when I plug in 5/3, and again, this is no fun at all, but you're not going to see a ton of these that are this tedious on a calculator or on a non-calculator section. So I'm going to plug in 5/3 and I'm cubing it. So it's 125 over 27 minus a 4 times 25/9, right? Plus a 5 times 5/3 minus, and then when I plug in 1, I get 1 minus 4 plus 5. So it should be a minus 2. So this is super good fun times. It's not really, I was teasing. So I get this 125 over 27. This is 100 over 9, but I kind of need it to be over 27, so it's a 300 over 27, right? This is a 25 over 3, but again, I kind of want it to be over 27. So I'm going to times by 9, which I don't really feel like doing, but 25, that should be 225. So this is 225 over 27. And then this guy ends up netting to being a minus 2, which would be minus a 54 over 27. Good times, so much fun. So I'm going to put the negatives together. I'm going to recognize that together I have a negative 354 and I have a positive, come on brain, 350? Right. And so together, these guys end up giving me a negative 4. So I'm going to realize that this is a negative 4 over 27, which means that the positive version is a 4/27. Like that's how far I traveled in the second leg. The third leg is about the same amount of fun as the second leg, which you can see why we're happy when these are a calculator problem. So I'm going to go ahead and plug into this with a 5/3 and a 2. Now I'm going to make the argument that you just did the 5/3, right? You just so you could arguably say that you just figured out what the 5/3 is. Like this right here is what happened when you plugged in 5/3. Like if you get rid of the 54, this is what happened. So if you get rid of the 54, this is a 350 minus 300. This is a 50 over 27. That's worth noting because when I go to plug this 5/3 in, it makes my life a lot easier. So I'm going to get that this is 8 minus 4 times 4, which would be 16, plus a 10, minus, and then I already figured out that when I plugged in the 5/3 before, it was a 50 over 27. So let's just stick with that and not absolutely destroy our souls by doing it over again. So I'm pretty sure I get 2 minus a 50 over 27, right? Which is a 54 over 27, right? Or a 420, minus 50, my bad. I skipped the minus 50. So minus 50 over 27, which is another 4 over 27. It's already positive. So after all that work, it turns out that my total distance, right? So total distance should be the value I had the first time, which I think was a 2, right? So 2 plus 4 over 27 plus another 4 over 27. That's a 54 over 27 plus 8 over 27. So I think my total distance is 62 over 27, and that's disgusting and not fun at all. So if we were to check this, right, you're not going to see a lot of these. So back in the day, this was a fairly common AP free response problem to make you work this out. The AP cares a lot less about these tedious problems now and a lot more about your comprehension. So you're less likely to see this now, but I just want to throw that out there that it's technically a possibility. Let's go ahead and check it by changing my y1 to 3x squared. So I don't want you to feel underprepared. I don't want you not to have seen these problems, but I want to point out that in terms of how tedious this is, it's less likely to show up on your AP. So I'm going to hit second enter, right? And this time I'm going from 0 to 2, and I've already changed my y1 to be the right function, and we do this, right? And then we do math, frac. Oh, it didn't frac for me, so that could mean because it's an approximation, let's check and see what we get when we do this. Let's see if we get approximately the same answer when we do 62 over 27, because sometimes when your calculator is approximating, it won't let you math frac, and there you go, it is a correct answer. Your calculator is approximating when it integrates, so if it's a really ugly integral, sometimes it doesn't pan out quite right. All right, so you're going to go ahead and try this one. Same idea. I know it's tedious. Remember that on an AP, you're probably not going to have to do one of these by hand, but it's good to understand the concept in case you did. So remember, the first thing I have to do is find where this particle is stopping, right? I need to find where v is 0. So 0 equals 4t squared minus 12t. I'm pretty sure I can take out a 4t and be left with a t minus 3. So it looks to me like it's just t is 0 and t is 3. Well, that's nice because I'm only going from 0 to 4. So basically, my total distance, right, my total distance is going to be, so leg 1, right, leg 1 is going to be from 0 to 3. Leg 2 is going to be from 3 to 4. So essentially, I just need to integrate and find the displacement on each of those intervals and then make them positive. So my total distance is going to be the integral from 0 to 3 of v of t dt, made it positive, plus the integral from 3 to 4 of v of t dt, and make the entire outside thing positive. So I'm going to just do a little bit of work and recognize that, that v of t integrates to be a, so I'd up the power by 1 divided by the new power, a 4/3 t cubed minus a 6t squared, right? That's going to be helpful to me because now when I plug in those values from 0 and 3, right? So for leg 1, this is going to be, I plug in a 3, so it's going to be a 4/3 of a 27 minus a 6 times a 9, minus a bunch of 0, so that's nice, right? So this is going to end up being, I can cancel the 3 and the 27, so I end up getting a 4 times a 9, so I get 36 minus 54, right, which is a negative 18, but I recognize that I want to make it a positive 18, right? Right, I want the positive distance. From 3 to 4, we already saw that when we plug in 3, we end up getting a negative 18, right? So when I do 3 to 4, I can go ahead and plug in 4. This is going to be 4/3 of a 64 minus 6 times 16, right? Minus, and then we already saw what happens when I plugged in 3. I got a negative 18, so it'd be minus a negative 18. So we can clean this up. I can't make it better than 64 times 4 over 3. Like it's a 256 over 3, but I can't make that much better, right? Minus a 96 plus an 18, right? This is going to net positive because you can see that, so 256. So if you didn't have a calculator, you would probably have to do, sorry, it's not going to net positive, my bad. Yes, it is, my bad. Okay, so 256 over 3. If I multiply 96 by 3, the easiest thing to do is pretend it's 100 times 3, which would be 300, right? But you're 4 short of 100, so you're going to be 12 short. So this should end up being a 288 over 3, and then this is a 54 over 3, right? So together, these are 310. 310 minus the 288 should be a 22. So I think I get 22 over 3, right, which is already positive. So I'm pretty sure that my total distance should be an 18 plus a 22 over 3, which is a 54 over 3 plus a 22 over 3, which, if we scroll down, should give me a 76 over 3, which is not divisible by 3. So then what we can do is we can go to my y equals, right? I can change this to, I think it was a 4x squared minus 12x. We'll find out in a sec. 4x squared minus 12x. Delete that. Let's go ahead and scroll up and make sure I was right. 4x squared minus 12x. Yep. Okay, so we quit out of here, and then this time, so second, enter, second, enter, second, enter. There we go. This time we're integrating from 0 to 4. Everything else should have been changed. I hit enter, and we can go ahead and math frac. And there's my 76 over 3, which is our answer. So again, kind of tedious, but don't panic. You're not going to have to do a bunch of those. So this is a non-calculator one. We're going to do total distance, but I'm going to argue that this one's not awful, right? Again, these non-calculator ones are a little bit more tedious. So the first thing I need in order to find total distance is I have to know when velocity is 0. So I have to find velocity, and this is going to be a product rule, right? So my v of t is going to be u. dv is going to be a 3e to the 3t, right? Plus v, which is e to the 3t, du, which is a 2. So I'm going to get 6t e to the 3t plus 2e to the 3t, and I'm going to factor. So my v of t, I can take out a 2e to the 3t, and I seem to be left with 3t plus 1. So this thing is positive. T times 3e to the t is positive, 2 times 3 to the t is positive because 2 is a positive number and e to the 3t is positive. But this thing can equal 0, so 3t plus 1 equals 0 when t equals negative 1/3. Well, this is not in the interval, which is nice, because since it's not in the interval, that means that this particle doesn't stop at any point in the interval I'm given. So displacement equals, essentially displacement and distance are the same, it's just a matter of the sign. So I don't have to worry about that stop. So essentially, to find my distance, I really just need to know what x of 0 is, which is going to be 0 times e to the 0, which is 0. And I need to know what x of 2 is, right, which is 2 times 2 e to the 3 times 2. So that's a 4 e to the 6th. So my distance is just essentially the positive version of my final position minus my starting position, which is just going to be a 4 e to the 6th, right? And that's it, right? Now you could also try and find that, but there's not, since you weren't given velocity, it doesn't really make sense to use your calculator to do that. Again, I would have had to be a little bit more concerned if my time, right, if that time -1/3 had fallen in the window from 0 to 2, but it didn't. I still have to find that time because sometimes it does. So same idea, non-calculator. If we're finding total distance, we need to know when we stop, right? So we need to know when v is 0. So again, I have a product rule. So v of t is going to be u dv plus v du, right? So u dv plus v du, when I factor this, I can take out an e to the t, and I'm left with cosine of t plus sine of t, right? So we want when this is 0. Well, 0 equals e to the t is a lie, right? E to the t is positive. But 0 can equal cosine t plus sine t, because what that's saying is cosine of t equals negative sine t. That's saying that the x on the unit circle is the opposite sign of the y on the unit circle, and that happens here and here. But since I was given the window from 0 to pi, this is the only one that's pertinent to me. So the one that matters is that t is 3 pi over 4. So basically what I'm going to have to do is I'm going to have to find the position at those 3 spots. I need to find x of 0, I need to find x of 3 pi over 4, and I need to find x of pi. And once I find those 3 spots, I just find how far I traveled on each leg, because those are the only places I stopped. So it's e to the t sine t. So this is going to be e to the 0 sine of 0, which is just a 0, right? This is going to be e to the 3 pi over 4 times the sine of 3 pi over 4 is a positive root 2 over 2, right? That's the number. And then this one is going to be e to the pi sine of pi, which is going to be 0, right? So that's a 0. So these are my 3 positions, right? So how far did I travel on each leg? Well, on this leg, I traveled this quantity minus this quantity, because this is a positive number. So I traveled root 2 over 2 e to the 3 pi over 4. On this leg, I also traveled positive number minus the 0, which is also a root 2 over 2 e to the 3 pi over 4. So this is how far I traveled on the 2 legs. So my total distance is 2 of those, which is just going to be root 2 e to the 3 pi over 4, because it's a 4, because there was a half for each one. So my total distance is that value, right? Again, not an easy check on your calculator, aside from the fact that you could plug in these 3 numbers and verify that you got the right values, but that's the gist. All right, so let's do something with a little bit of tricky wording. We have 2 examples left. So on a particular, a graph of a particle's velocity is given below. From 0 to 3, the particle's displacement is 6, and the particle travels a total distance of 10. What is the value of this given integral? Okay, so first thing you need to do is translate what this means, okay? So if the particle's displacement is 6, right? Particle's displacement is 6 translates to the fact that the integral from 0 to 3 of v of t dt is a total of 6, right? Like that's what would happen if you integrate it. But if you integrate the absolute value, so the particle's total distance is 10, right? So if you integrate from 0 to 3 of the absolute value of v of t, you get a 10. All right, so here's what I want you to get from that. Okay, let me erase so I can. So again, this is tricky. This is about understanding how graphs work. I'm integrating from here to here. Essentially, this red thing is this negative area, right? This area that's clearly negative, plus this positive area gives me 6, right? This negative area plus some positive area gives me 6. But when I integrate the absolute value of v, the absolute value of v looks like, oh, sorry, wrong color. The absolute value of v looks like this. It flips up the negative stuff and does this. Okay? So for the absolute value of v, this negative value now becomes positive. So let's just for our sake call these things letters. Okay, let's call this area A and call this area B. 6 is area A, right? So essentially 6 is area A, whatever this number is, right, as a negative plus B, right? It's negative A because it's below the axis. But 10 would be whatever that value is flipped up to the positive, so A plus B would be 10. So essentially what I can say is I get that negative A plus B is 6, and A plus B is 10, right? So if I use systems of equations, and I could just add straight down and use elimination, I get 2b is 16, so b is an 8. Once I know b is an 8, I can say, oh, so a must be 2, right? Because once I know b is 8, I get a plus 8 is a 10. A must be 2. So here's what your graph actually looks like. If we come back up here for a sec, and this will jive really well if you look at the numbers, this is an area of 2, and this is an area of 8. If I did the absolute value of this, it would be positive 2, positive 8, and there's my 10. If 2 were below the axis, it would be a negative 2, because below the axis and an 8, and that's my 6, right? So when I'm asked what's the integral from 0 to 1 of this function, well, it's a negative 2, because it's this window. It's this window that's a 2, but it's below the axis, so it's a negative 2. Again, that's a tricky way to think about it, but this is the kind of thing an AP might ask on a multiple choice, right? Because it's requiring comprehension without a whole lot of math, right? So the particle's displacement from 0 to 3 is 1, meaning if I add area A, and then let's call this area B, right? So what that's saying is A minus B apparently gives me a 1, right? But the particle's total distance is 13, meaning A and then a positive version of B, right? So A plus B would give me a 13. So 2A should give me a 14. A is 7, right? Once I know that this is a 7, I can logic out what the rest is, right? So I know A is 7. I can either go up here and say, okay, cool, that means that B must be a 6 because it's 13, so B is a 6. Or I could actually like logic it through based on what the sums should be, right? What I was asked for was I was asked for this integral from 0 to 2, right? So 0 to 2 is just going to be a 7, right? Because this, if you look, 7 minus 6 would give me a displacement of 1. 7 plus the positive version of that negative 6 would give me a 13, right? So my answer is 7. All right, and that is it for our second video.